So 3.5b, here's the quiz answers for this. 1 is the set of all points. Make sure they have the word all in there. If they just say set of points, that isn't it. Set of all points is very different. Everything's a set of points. Segments, rays, lines. But space is a set of all points. 2 is dotted. 3 is pencils or some synonym. 4 would be cardboard or some sort of a synonym. 5 is if there's a plane that contains all those points. 6 is if there's a line that contains all of those points. 7 does a countdown, 3, 2, 1. There's 3 non-collinear points. The non-collinear is an important phrase. If they shorted that, that doesn't do it. 3 non-collinear points, 2 intersecting lines, and then the last choice is a line, and then a point that's not on that line. A line and a point that's not on that line. 10, we need to mention the phrase in the set twice. If you don't see the in the set phrasing twice, then something funny has happened there. They'd be out at least a half on that. Something like for any 2 points P and Q that are in the set, the entire segment PQ is also in the set. 11, you could either draw a thing like this or a Pac-Man kind of thing where your idea is to include the inside, or you could even just like draw a circle and put a note, I'm not including the inside. 12, convex, you could do like a circle or a triangle or pretty much any shape and like shade it in to include the inside. Basically anything in 11 that has a gap or a hole, not convex, and then 12, something that doesn't have a gap or hole, it is going to be convex. 13 was the 7 bridges of Königsberg, where Königsberg doesn't have to be spelled correctly, but at least close enough that you know what they're trying to do with that. If they just said 7 bridges, we'll go half, because I had said yesterday we were looking to throw the city name in there. If they just said bridges, I guess I'll go half, but that's not really much to go on. But 7 should be in there, bridges should be in there, the city should be in there, or some attempt to spell Königsberg. 14's Euler. I didn't say you had to spell him right on the test, you probably do, but that's E-U-L-E-R for Euler. 15 was that you couldn't cross all the bridges, couldn't be done. 16 is topology, lots of O's in that, T-O-P-O-L-O-G-Y, and then he was blind. So 55, we're just trying to fill in the blanks here, mostly with collinears and coplanars and words like that on most of this homework. Do you have a theory on what?
Collinear?
It is collinear. You have a theory on 2? It is coplanar. You have a theory on 3? I'm going to say at least 3 non-collinear as a perfect answer, but that was pretty good. 4 is all points. 5? Right idea, wrong number. 4. Yeah, at least 4 non-coplanar points is 5. 6 is different. 7. No. Try another person. 7? Okay. 7? Got it. Is same. That was the thing about different, same. If I use a number, things have to be different. If I don't use a number, maybe they're the same. Question 1 to 7. 8. Possible answers for 8 would be collinear, or coplanar, or both, or neither. That is our options. So collinear, coplanar, both, or neither. Have you ever thought on A?
I didn't.
Okay. Thought on A? Is coplanar. To B? Disagree. Different thought on B? I was going for our next person in line. But it's neither on 8B. Back to the front, 8C, a thought or no?
Is that collinear and coplanar?
It is both. That is true. D is coplanar. E is coplanar. F. Okay. Try next person up. We'll try next person up. Neither. Next person up.
Linear?
Try next person up. No go. Next person up. It is both. That one is also both. So if we look through the answers we just did, what answer never happened? Collinear only. Why did that never happen?
Because something can't be only collinear.
It can't be only collinear. If something's collinear, it has to be
Coplanar.
coplanar. So on 8 and as we go into 9, anything that you're saying collinear, you can't just say collinear. You have to say collinear and coplanar both. There were some neithers, and there were some coplanars. Let's see. We'd be trying Nicole for 9. A is coplanar. If you have anything in this set you said collinear, we just decided we need to change that answer to both. 9B is going to be both. 9C. We were just going to the next person if they're ready. Or you could pass. Yeah. Give a 9C shot or pass it off. Disagree? Give it a shot at 9C.
It's 9C coplanar.
It is coplanar. 9D is coplanar. 9E is neither. 10. Give a shot at 10.
Is it just one?
Disagree? Done it? Done it? 10? Good shot?
Well, I said what line and lines and 6 lines.
I disagree with that first one. We'll just try for the first one for now. Give a shot at that first answer.
Is it 0 lines, 1 line, and 2 lines?
Disagree? No go on this, right? Infinite. It is infinity for the first question. Second question at 10, we'll try Lauren. No go? Second part of 10 or no go? Second part of 10
It's 1.
is 1. Third part of 10? No, no. Third part of 10? It's got to be a number. Anybody third part of 10?
Is it 3?
That's half right.
Is it at least exactly 3?
No.
At most 3?
Thought it was.
It is at most 3. We could say that maybe. Let's say 3 or something. No.
3 or less.
3 or another number. 3 or 1. Either 1 or 3 on that one. 11. Anybody have a thought on 11? It is using the line postulate. That's true. What do we know about the lines though because of that? They ask, what do we know about these lines? The line postulate is what they're talking about.
They're both collinear.
That's true. In other words, they're the same line on 11. 12, anybody have a thought? I'll tell you, it's the same point. That's theorem 3-1. 13, anybody have a thought? It is 0. 14 is going to go true, true, false. 15 is going to be no, yes, yes. 16, 16 is like so easy that sometimes people end up feeling like it's hard. They're not on the same line. Non-collinear is the word we're looking for there. And then did we do 17?
No, it's not.
Stopped at 16? Okay, so we've got some, I think, cleanup to do there, because that seemed sort of rough. So what, maybe hearing the answers made you go, oh, okay. But maybe hearing the answers makes you think, huh, how are they doing this? Something to clean? Anybody, anything on this that you had still, you're just like, what?
10.
10? Okay, so 10, if I draw 1 point on the board, and I try to draw a line that's gonna touch it, how many options do I have?
Infinite.
Infinite. I can sit there all day drawing different lines all day long. If I do 2 points on my board, and I wanna do a line that's gonna get them,
One.
I only have one line. That's the line postulate. If I draw 3 points, well, 3 always depends with lines, because I could draw 3 points that make a triangle, in which case, can I get them all? No. Or those 3 points could
Be on the line.
be on a line, and then I could get them just with that one line. 10, I don't know if we said the right answer the first time through on 10. 10 should be either 0 or 1. Because they're wanting to contain all of them.
I thought we
Did
said
I say 1 or 3?
or
Yeah.
1.
Yeah, I take back my 1 or 3. If I phrased a different sort of question, that would be true. If I asked you how many lines could contain 2 of them at a time, or how many lines they determined, it would have been 1 or 3. But if we're having to get through all of them, either we can't, or there's one choice. So either 0 or 1. I retract that original answer on 10. Somebody asked about 10. Is that your question?
Yeah.
Does that make sense?
Yeah, that was confused by the original answer.
Anybody 10 or anything else that you heard the answer now and you're wondering what was going on? Anything? 55? If that's reasonably good, send it down. If you need that to like brush up on some things, then keep it. We pop up to 59. 59, the first question, answers are in the back. If you're stealing answers from the back, you're cheating, so don't do that. But I might as well just make sure they're publicly known because they're back there, and then we'll get people to maybe share some even answers. For one, the situation is that that line is in that same plane. What thing is that if we're talking about lines being in the same plane? That is the flat plane postulate. 2. Anybody have a theory on, well, I'll say this, before I set you up on a yes/no question and you whiff on it, it is a no. Can anybody explain why 2 is a no?
A line must always be coherent.
They're asking you, if you think about intersecting lines, what do intersecting lines look like most of the time?
Cross.
Yeah, like make an X. So intersecting lines usually look like this. If the lines look like this, does this intersection contain 1 point? Yes, but that's not an always. 2 lines don't always have to make an X. What's another play you could make? No, that would still, because lines go forever. So, like, that's still a variation on that. Other than lines going like this, what else can lines do? They could be parallel. And if they're parallel, do they intersect in a point?
Yeah.
No. What is the intersection when we go parallel? That's the empty set. Yeah, right idea, but that would be empty set. 3 is, you need 3 points to name them. 4, they drew you a picture. Which postulate is that picture about? That is the intersection of planes postulate. 5 is coming from the quiz. That's the 3, 2, 1 countdown. So I don't really feel like saying that one. We've had that a bunch of times. 6. Anybody have a thought on 6? We picture 1 point. We're trying to figure out how many planes can go through it.
Infinite.
That is infinite. 2 points. How many planes can go through it? also infinite. 3 points, planes that go through it.
One.
Maybe. Maybe. Well, how do we know?
One.
One or infinite. They're both a plane. How's it one plane gets them all? If they're non-collinear. Infinite planes get them if they lined up. So it's the 3 points. You always have to be suspicious of whether they line up or triangle for you. They usually give you 2 options. 7, they want us to draw a plane. And then they want us to do a line segment that lies in that plane. So there I go. That is a line segment in my plane. How do you know on my drawing that that's in the plane and not like coming in or going out?
Because it's a solid line.
It's a solid line. Now when we go to do a line segment that touches it in one point, but doesn't intersect the other segment, I need to go over here somewhere. And if we're touching it in one point, I'm going to need to be like going in and out of the board. So how are we going to show we're touching it in one point going in and out of the board?
Dotted line.
Something dotted. So like maybe that's coming out at you and that's going behind. So that would be a segment that because I did some of it dotted, you know, some of it's behind, this has to be solid then coming out at you, and that's the one point where it touches. That's what we're after on 7. 8, there's a line and a plane, 2 points in common. What do we know? It's a term we already had earlier in the period of this homework page today. There's 2 points of a line and a plane. What is this thing?
Convex.
Some sort of thing we learned talking about 2 points of a line being in a plane.
The line has to be.
Yeah, the line's in the same plane. Yeah, what is that thing called?
It's the.
That's the flat plane postulate. 8's talking about 2 points of a line being in a plane. The thing that they want you to say is that the line is in the same plane, and the reason would be flat plane postulate. 9, I got a really funny answer on 9 once. So geometry, history, when we get to some of the tests, some of the silly things that people have done and said have appeared on the tests. At the end of the year for the final, everybody's entitled to a question. So someday there could be a Dave question. It could be anything you want it to be. It could be about geometry, could be a thing that happened this year, could be about anything at all. If you guys make it to the final, you're all entitled to have a question on the final. This was somebody's question on the final because they said this themselves and they thought it was funny and they sponsored this question. They said on a level floor, a four-legged table rocks while a three-legged table is always steady. They said it's because the earth was round. And that is not at all what that has to do with, but that was an actual answer once given by an actual geometry student. That the four-legged things rock while three-legged things are steady because the earth was round. So he said it, his friends sort of teased him, he laughed at himself, and eventually grew to like that question and sponsored that question later. We're looking for something that has to do with this chapter. There's some 4s in this chapter. There's some 3s in this chapter. Something in this chapter that has to do with 4s or 3s. Anybody have a theory on why four-legged things rock and three-leggeds don't? It has to do with planes and space, yes. Can anybody translate from 3s and 4s and planes and space to a question that has to do with a real-world event?
It's the super little bridge things.
No, not necessarily.
Isn't it like 4 non-collinear points can't
The 3 points are always
be coplanar?
coplanar. Okay, so I think most of our floors are flat in most of our areas where we live and go. So if you have a three-legged thing with 3 contact points, those 3 points are all going to touch the floor, the plane. If you throw in a 4th point, is that coplanar? Maybe, maybe not. So maybe it rocks, maybe it doesn't. Okay, but what 9's about, 3 points will always be in a plane and will not rock. 4 points maybe, maybe not. So that's why your four-legged stuff sometimes wrongs. 10, the same person, for 10, after they had come up with the earth was round, they came back on 10 with the device used by surveyors and photographers that make use of the plane postulate was a camera. So while it is true that a camera does get used by a photographer, cameras have nothing to do with this chapter. The plane postulate has to do with threes. What device a photographer uses has something to do with threes. A tripod. So we're talking here about tripods, not about cameras. But that's what 11 or 10 is supposed to do. Did you put a camera?
I also.
And now you realize it's sort of a silly answer?
Actually, go.